So many technical difficulties right at the last moment. Welcome so much. Thank you so much for being here, everyone. And thank you, Sanjay Bhatia, for being our guest today and teaching us about Project Contour. Sanjay, tell us about yourself, please.
Hey everyone, my name's Sanjay. I'm an engineer at VMware and a maintainer of the Contour Ingress controller. Also a contributor to Gateway API and a few other CNCF projects. Happy to be here and talking about Contour.
A few other CNCF projects. Yeah, you're just like casually like a maintainer on or a contributor to a bunch of different projects.
Yeah. So Gateway API is the big one. It's a kind of the future of service networking in Kubernetes. As part of the Contour team, as part of VMware, we're super excited about it. Trying to push it forward and help out where we can, and um, yeah, promote that project and get it to the level of adoption that native Ingress has in Kubernetes. Yeah.
Awesome. I have many questions about that, but I'm going to save that particular topic for when we're behind the light board because I think we're going to want to write that down. But let's say hi to some friends in chat. Napalm's here. Hi, Napalm. Napalm's so annoyed that they missed Nginx Ingress yesterday. So I've been doing a little series on Ingresses on the CNCF specific ones. So we've talked about Emissary Ingress already, and that was like last month or maybe 6 weeks ago. And we yesterday talked about Nginx Ingress, and now today we're doing Contour. And this is new for me in the format of the show to try to lump in a bunch of related technologies, but I think it's really great to be having these conversations one after another because we have a lot of context from the other things. So you said, Sanjay, for example, that you watched the show yesterday. And so since James already did a lot of talk about like the different networking models in Kubernetes, for example, maybe we don't have to go quite into detail unless it's super relevant to today's story. We can maybe just point at that episode, which actually I'm going to link to it right now. So as we talk about Ingress stuff, yesterday with James, we went in pretty deep on the different types of Kubernetes services and also the Kubernetes networking model. So if you want to learn more about that, check out yesterday's episode. But of course, not right now. Hang out with us right now. So that is exciting. And one thing we haven't really touched on yet in terms of the overall Ingress space that I'm excited to talk about with you is especially that Gateway API. So Napalm, thank you for us. Napalm says also, hope you're well. I hope you're well too, Napalm. We have a hello, Sanjay from Steve Sloka. We have hi Whitney. Hi, Sanjay. Hello. Vice Verix here. I always love to see what you're here. You'll always add so much to the stream. Thank you. Winnie's here. Hello, Winnie. Thank you so much for coming. And another hello. Hey y'all. Hello. I love that y'all are saying hello. And also, if anyone thinks to say where they're from, I want to hear about that too. Where are you talking to us from right now, Sanjay?
I'm in Richmond, Virginia. It's Central Virginia, a couple hours away from DC. Yeah.
Cool. How did you get how did you get into networking? Is it something that's always kind of called to you or?
Yeah. So uh, originally, before I was on the Contour team, I was working on Envoy Proxy, which is the data plane for Contour, as part of one of the teams at VMware that was focused on bringing Windows support to Envoy, so porting it over to Windows so that you could run it on Windows nodes, particularly in Kubernetes or any other sort of containerized platform. And then, got an opportunity to work with the Contour team and become a maintainer. And since then, it's been a hit.
Awesome. That's fantastic. I will say too that I'm here in Austin, Texas. So I love I say this often in these episodes, but I just I'm in my 40s. I remember a time before the internet period, and just the fact that we can have this conversation from across the country and across the world in real time is just so incredible. I love it. So we're going to move behind the light board. I would love to hear from y'all. Oh, Simon's here. Scott's here. Hi, Simon. Hi, Scott. I'd love to hear from y'all. What Ingress implementation are you currently using? Or if you're just learning about Ingress, what's something that you want to know? Ingress, especially more than any other like Kubernetes core concept, I think, is really hard to understand at first. And it's really like kind of a big confusing mess in terms of just vocabulary and concepts. And I've been doing this for a while now, and I feel like I'm only beginning to untangle it in my mind and get my mental model straight. Napalm agrees. Napalm says Ingress is complicated as all get out. It's true. So let's untangle it a little more today. Let's get a few more threads unraveled. And then also, so please let us know your experience. And then Sanjay, what you want to talk about is how, if someone's interested in contributing, what's the path for that? And I'm going to drop a link into chat to check out too. And I'm going to get my little booty back behind that light board while you talk. Thank you.
Yeah, so Contour is a CNCF project where it's all open source, and we really want to grow the contributor community and the maintainer community as well. So the best way to do that is if you're a user of Contour, even if you're not a user of Contour, our GitHub page has a whole bunch of issues that should be tagged as some that are good for first-time contributors, some things that we would like the community to drive, like users and contributors to drive forward. This should be all tagged in our GitHub project. In addition, just coming in to talk to us on Slack in the Kubernetes Slack workspace, the Contour channel. Any of those avenues to get involved with the maintainers, get involved with the other contributors, are great to see. And I think Whitney put up a link on some of the roles that we have established in the community, and we're trying to kind of show that we have like a path forward for to kind of grow your influence in the project and grow your standing in the project. So there's a few roles. You can be a contributor or a viewer, and then ultimately, if the end goal for you is to become a maintainer, there's definitely a path forward for that. Something that if you're an organization that you're part of an organization that uses Contour as an Ingress controller, and you would like to be able to have some ability to help out with the kind of release engineering process, the actual features that are getting added to Contour, security review, any of that stuff. It doesn't have to just be doing like in-depth designs and reviews of features. We also definitely need help with some of the day-to-day maintenance of the project, managing CI, security review, security analysis, release engineering, all of that. So please let us know, get involved, and we can always make more roles available. There's definitely a lot of potential work to be done in improving documentation, everything that a software project, anything you can imagine in a software project, we probably could use someone to help us out with that. So definitely come drop us a line on Slack, on GitHub, wherever, and we'd love to have you get involved.
I think there are a couple. As someone new to tech and a little bit shy, especially when I was first involved to like get out there, like afraid of being judged or whatever. There are a couple things you said. One is I love that you're pointing out that there's a lot of ways to contribute that aren't just code contributions. That's wonderful. And then another thing is when I hung out with some SIG. I like contributed a little bit to SIG docs before I got busy in the Kubernetes project, and it really helped me to go to the community meetings and like get to know everyone as people and like have a real relationship with them. So when I'm interacting with them on Slack or whatever, that there's a face behind the name, and I know it's a friendly person, and I know they want to help and they want me to do my best. And um, so I don't know if you already said it because I'm a little bit distracted moving, but attending the community meetings I think is a great way to get started too.
Yeah, definitely. We have kind of turned them on and off recently due to just scheduling and whatnot. But
Uh-huh.
please, if you would like to have a particular time zone in mind, or if you want to come to more of an office hours type session versus like a community meeting with a set agenda, please let us know, and we can try to make these things available. Yeah, we love hearing from people. We had the I think it was SIGDOC's working group, a group of people come and get involved with Contour through that path. We had a community managers promoting that really well, and we got some great contributions for the website, documentation, accessibility analysis of the website, everything that you can imagine you'd want to do on a uh, growing your skills in web programming, even helping out with the
Oh,
documentation. We'd love to have you. So yeah.
amazing. Uh, I went through a coding boot camp, so if you remind me, I'll post about like a web dev opportunity in my student Slack of the alumni, because they're when people right when they graduate from coding boot camp, they're very eager to get their hands dirty with something real. I'm having technical issues with my iPad, but that's y'all don't need to worry. The worst that'll happen is I'll be slow to highlight comments. But we have some great comments, by the way, which I'm going to highlight from over here. All right, what iPad? So yeah. Okay, so let me remove this from stream. So uh, there we go. All right, we're in though. So now we have some great comments. We have Little Helper Boat saying, giving. I'm so glad you're here, Little Helper Boat. Welcome, welcome. Giving Contour some strength arms. But David Espejo saying this show gives me some DGIK vibes, which I take as a huge compliment. Thank you, David. And then Simon giving some context, currently trying to scale out my Pi farm. So looking into load balancing clustering options, and further down want to integrate some power up, power down scripts. Super cool. That's awesome. All right. So what I'd like to start, we have some context about Ingress in general, but one thing that makes Ingress so confusing is there's the Ingress objects, Kubernetes objects, and then there's Ingress implementations, which is the controller needed to, the Kubernetes controller for those Ingress objects. And then as soon as you look at Ingress implementations on like the Kubernetes webpage, there are like 20 of them. And then they all like some of them mention Envoy, some of them mention Nginx, some of them say Gateway, and I there as a beginner I just have no idea what I'm even thinking about. So the question in there is, I don't know how old or what point in this that Contour came into play, but what was the landscape like before Contour existed, and what made someone say, you know what we need is another Ingress controller, and then go on to make Contour?
Yeah, I think some of that was I believe Nginx Ingress has existed for longer than Contour, and I think
Uh-huh.
some of the reason that Contour was created was one, to use Envoy as a data plane. Envoy
Okay.
is kind of become an industry standard in some circles at this point, but Envoy as a reverse proxy and service load balancer has been was like a very exciting, slightly newer technology that has had some market, what some would say, advantages and features that were advantageous over something like Nginx. So dynamic configuration reloading over the XDS protocol. So we can dig into all of this, all the terms here in a second. The fact that it's developed in C++ and tested very well, and uh, uh, load tested at large organizations like Lyft, where it was developed. Um,
Ah,
um, uh, so things like that. Envoy was an exciting piece to use as a data plane component, as well as kind of wanting to improve on Ingress, the Ingress native Ingress v1 object. That's another reason why Contour kind of stands out and why it has been relevant. So yeah, so making changes to Ingress v1 itself. It's a core Kubernetes object that takes a long time, a lot of uh, discussion in the community, and changes will happen in Kubernetes versions, which don't come out super often, right? That's not on the same release
uh-huh.
cycle as like a independent controller component that you can manage yourself or have CRDs for yourself. So some kind of conceptual differences that large organizations or people with certain types of operational concerns might have wanted to um, uh, have with when they're programming Ingress and managing various clusters. So
Amazing. So I'm going to dig into everything you just said a little more. Do you feel like, wait, are there other reasons why Contour was created, or are those like the two main ones?
I think those would be good ones to focus on. Yeah, definitely.
Okay, amazing. Then I want to quickly. So why Envoy? First of all, just what do you mean when you say data plane?
Yeah, so I think we can think of something like an Ingress controller as kind of two components, the control plane and the data plane. So this is similar to other other concepts in distributed computing, other concepts in Kubernetes. You
Mm-hmm.
have one of a component that takes in configuration, takes in desired state of the world. For example, in Contour, that's the Contour the main Contour controller, the XDS
Mm-hmm.
server that takes in configuration and makes decisions about it, and is actually what's going to then that you're going to use that to program your data plane. So the data plane is the thing that actually does the work of um, servicing requests to your cluster in the context of Ingress. So
So the
uh,
control plane is concerned with the actual versus the desired state.
yeah, so the
Is it
control plane
okay?
is something that's going to take configuration and then make that configuration happen in the data plane. And the data plane is the component of an Ingress controller or some other distributed system that is actually processing data. So think about like configuration input to the control plane and actual data input to the data plane.
Oh, I like that. I like that framing. Control plane. Okay. So configuration input.
Yeah. So in terms of input, yeah, I guess if we want to model it as an input and output diagram or something like that,
Uh-huh.
or um, the input to the control plane is possibly configuration, and the output is um, uh, is user desired state, and the output is configuration of the data plane. And the input to the data plane, given that state of configuration that the control plane has made, the data plane takes, for example, user input or HTTP requests or something like that, or someone wants
Hmm.
to run a workload on a worker node in a Kubernetes cluster, actually does the actual work of processing that.
So the output of the control plane is data plane configuration?
Yeah, yeah.
Okay. Excellent. This is very helpful. And then the data plane does the work.
Yeah, that's where you would put in a Ingress controller context. That would be your proxy. That is then actually doing the processing of requests from users and sending it to your applications that um, are processing those requests for your business logic.
It does when you say, so it routes the request and processes them?
Yeah, it routes your request. I guess that's what I kind of mean by processing in the context of
Okay.
proxy. It's routing your
Yeah,
requests,
yeah.
potentially modifying them, doing the work that you express desire for into the control plane. That's the thing. That's yeah, exactly like you said.
Okay. Thank you for slowing down and explaining that.
Oh yeah, I
All
think
right.
I said it 3 times, but because I didn't say it well the first few times.
Well, it's not, I don't think it's a matter of saying it well or not well. It's a matter of bringing it down to the building blocks where my new learner brain can wrap my head around it. I think you probably said it very well to people who are already more familiar with the space. Um, so now I want to dig in, and you were pretty comprehensive of talking about why Envoy, but I also want to capture it on the board. So I'm going to have you repeat yourself, and maybe this can be more simple, like just a list of why Envoy.
Sure. Yeah. Envoy is a really well tested and and large community project at this point that has a lot of stakeholders across the industry. So
Uh-huh.
started at Lyft. Google is very heavily involved. Other large companies that um, uh, have a stake in a secure and well tested, well written, extensible proxy, service proxy, and load balancer proxy. Um, in addition, definitely extensible. You can it supports custom extensions. It supports um, injecting scripting languages and all sorts of things. The developer experience for developing extensions is um, it's in you can write C++, you can write Golang, you can write Rust. So very extensible code base. Um, uh, I think I said, yeah, very well tested. The
Mm-hmm.
testing framework and testing uh, uh, infrastructure is pretty massive at this point. Every single commit, every single change is accompanied by very extensive tests, and the maintainer community is also very focused on that, as well as the kind of some of the more like nitty gritty features of the proxies. By nature, the Envoy uh, supports dynamic configuration reloading over um, a protocol called XDS, um, which
So like this is very like already the fact that we did the work of untangling this so that I understand that about more about the configuration being such an integral piece to this puzzle. So now I can understand why dynamic configuration reloading is very important. And as opposed to an older protocol you said that doesn't do that, what's the alternative?
yeah, so other implementations of a proxy may have something similar, but Envoy's XDS protocol is um, intended to be super scalable
Mm-hmm.
and uh, kind of proven to be so in the large organizations that use it. Other proxies may use like file-based configuration updating or things like that, where you kind of have to um, you may have to couple your control plane directly with your uh, uh, load balancer solution, and kind of be rewriting files, and or using a different protocol over the network or whatever. But the XDS protocol and Envoy's implementation of that is intended. It's kind of designed at a huge scale to start with, with a large control plane and data plane working together to implement Ingress or Service Mesh or everything. And,
Cool. Oh,
and yeah,
we have
Steve Sloka in the chat, one of the Contour maintainers, um, uh, the XDS protocol works over HTTP2, and has a lot of support, has good support for, like, what's the word I'm looking for? Uh, Not consistency, but basically making sure that your configuration updates go through correctly, and make sure that you can retry, and what's the word I'm looking for? Um, uh, yeah, so it solves kind of problems of dropping configuration and reloading configuration properly. So yeah, Envoy has a lot of advantages in terms of how it is configured and how you can update it, and maybe an even additional one is observability. Like, Envoy has a lot of statistics, and it's been modernized in supporting Prometheus metrics and all sorts of observability practices that are um, kind of the industry standard in recent years. So that makes Envoy a really good choice for being able to understand what's happening in your cluster really well, tracing requests, tracing how Envoy is performing, everything.
excellent. This is perfect. So I'm going to just repeat back to you what you said. Also, I'm going to say hi to Kormaju, who's hello from India. Thank you so much for coming. And Fuel Snobel's here too. Hi, Fuel Snobel. So Envoy's good because it's well tested. It has a large community, meaning new features will come out faster. Things, if ever, anything needs updating, it's better maintained. It's secure. It's extensible, so you can make custom extensions. You can inject scripting. You're flexible with language types. There's Rust, Go, and C++ are the ones you mentioned. Dynamic configuration reloading, which solves the problem of dropped connections, according to you and Steve in the chat. It's scalable. It can get to be very large. Specifically, it works well with very large clusters, and then it collects a lot of metrics. It's good for observability. Is that a good synopsis?
Yeah, and there's definitely more that we could add here, but these are some great compelling arguments for why you may want to use Envoy as part of your data plane.
Excellent. So then we have one more thing to unpack from your very simple and good explanation at the beginning for why Contour was created, and that is what were the limitations on the native Kubernetes Ingress object that need to be improved upon?
Yeah. So if we look at the structure of the Ingress object, it is pretty simple.
Mm-hmm.
You can specify what host names you want to provide Ingress for. You can provide what paths you want to match requests to. You can provide what services you would like to route these requests to. And you can provide, I believe, TLS certificates that you would like to present as part of your server, presenting to your clients. And I guess, and one of the things that Nginx Ingress and other implementations of Ingress controllers have taken advantage of is kind of the generic Kubernetes object metadata that you can add annotations to your Ingress resources.
Mm-hmm.
Uh, from the perspective of users that the Contour that ended up being Contour users, annotations can become, they're easy to implement, quick to implement, but they're also quite it's unstructured data. So
Mm-hmm.
managing the actual content of those and then ensuring consistent implementation of those across many implementations is
Mm-hmm.
not it's a little tricky. It gets a little
Complex.
complex after a while. So that's one aspect where Contour kind of doesn't, the Contour project doesn't would prefer to use structured resource specifications rather than annotations for that purpose, as well as kind of thinking about the different personas in the context that might be involved in the context of an implementing Ingress, and how different personas would need to do different things in.
Okay. I'm gonna stop you there. I want to hear about personas and definitely write down about personas. I want to acknowledge Kormaju's question. Does the data plane deal with storage data or routing traffic?
In the general sense, data plane can mean many things, but in the context of Ingress, it will mean routing traffic.
That is a very important distinction and a great question. And part of why Kubernetes can be so confusing to learn. In different contexts, the words data plane might mean totally different things. And then I'm really psyched to hear about Contour. I mean, that's why we're here today. And so now that you're actually getting into what Contour does, before we dig in on personas, I'd love to just get like a Contour is definition up on the board, and then we can dig into the personas. Does that sound good?
Sure.
So let's do the what is Contour question.
Contour is a Kubernetes Ingress controller that uses Envoy as the data plane, as the load balancer and service proxy. Contour supports dynamic configuration updates, and I think harkening back to the personas, and one of the kind of reasons why Contour exists is that the Contour core to Contour is the concept of multi-team or distributed multi-tenant, I guess you could say, Ingress delegation.
You're getting ahead of me. But so Contour is a Kubernetes Ingress controller that uses Envoy as a load balancer. And what was the other thing that Envoy does?
That's perfect. Yeah.
Yeah,
It
a
was just more
proxy.
words to the same effect.
Okay, that uses Envoy as a load balancer and a proxy, right? It routes the traffic. The
Yeah.
Envoy does the
Yeah.
actual routing.
Yes.
Yeah. Um, and is there anything else you want to put in this core definition before we get in? You were saying more. What else do you want to add to this?
I think we can get into, maybe we can leave it there, and then we can add more to the specifics of Contour in that context.
Okay.
Yeah.
Cool. Excellent. So I want to hear more specifics. It could be, we started talking about personas, which I don't want to drop, but we can postpone it. I won't forget, probably. So where do you want to take it next?
Yeah. So like kind of continuing on from where we're talking about the Ingress, and why Ingress is definitely very valuable and extremely useful, but
Uh-huh.
kind of core to Contour is kind of adding more on top of Ingress.
Okay.
So when we're talking about Ingress, and it is quite simple, right? And that's a good thing for many use cases. For if you don't need more than path-based routing and
Mm-hmm.
and whatnot, um, that's perfect. Contour implements Ingress, is conformant with the Ingress conformance test suite, all of that. Um, uh, when you start to have many teams for in many software teams, many different personas in an organization that's using Contour, that's when Contour when using Ingress, that's when kind of Contour starts to shine a bit. So
Okay.
we can kind of think of a few personas here that make sense to uh, talk about in the context of Ingress. Um, so
Excellent.
so we have, I think, at the 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 people deploying Contour. So maybe you could call this a cluster operator. So they uh, are making a Ingress controller available to um, teams that are running applications in a cluster. So they kind of manage the cluster. They manage some of the infrastructure software that's running in the cluster um, uh, to make that cluster work for application teams. Yeah.
They install and manage Ingress, like the traffic of the entire cluster.
Yeah.
Install Ingress, yeah,
So they
and
might be
manage the.
managing like the cloud provider integration with your load balancer. They might be deploying the actual Ingress controller itself, and
Mm-hmm.
then fielding uh, any issues that anyone has using that Ingress controller would possibly go to this team as well. So we want to kind of keep that sort of day two experience in mind as well.
Mm-hmm. Day two, day zero, day one, day two. Actually, let's actually say hi to young Nick's here. Hello, young Nick. Young Nick, at some point you won't be able to use that handle anymore. How long until you have to change it? Anyway, Kormaju says it asks, does Contour work with edge traffic?
Yeah. I mean, Contour can be deployed as an edge proxy. I mean, kind of hard. Going back to Simon's comment from YouTube about Raspberry Pi farm, there actually was a really great talk at KubeCon North America, I believe. Um, was it last year, where someone had a really great demo of showing Contour running on a Kubernetes cluster in a Raspberry Pi, um, and it was pretty amazing. Like using integrating something like Contour with those sort of devices and running that in that sort of constrained environment. That's totally applicable to all these use cases.
That's really fun. So we have our cluster operator, and it's like a team of people, probably ops folks. So they install Ingress, they manage traffic for the entire cluster. They're interested in integrating with the cloud and just keeping everything maintained and working. Young Nick says, "I used to work with the team on Contour." Excellent. Oh, well, you'll always be young at heart, Nick. All
Yeah,
right. Yeah.
that's Nick Young. Yeah, former. I think Nick Young will always be young
Ah,
Nick.
yes,
Yeah.
yes. Now that I know your actual name, Nick, I get it. Cool. Okay, so how does this cluster operator persona relate to Contour specifically?
Yeah, so they'll probably be making sure that the Contour installation is installed and available to users who are then going to um, configure routing for in their cluster. So they're probably doing some of the setup and global configuration of Contour, maybe setting up certain global policies that'll apply to all routes that get applied to this Ingress
Mm-hmm.
controller. Um, So they're kind of an administrator operations uh, uh, persona. Yeah.
So with Contour specifically, they might set up Contour, they might set global policies.
Yep. For example, if you want certain request headers to be set on all requests that are proxied by Contour, you might you might that might be something that the cluster operator does, like some sort of corporate policy or something like that.
Mm-hmm.
Things like that. And we have a question from Andorino. Sorry, I'm lost. I thought that native Kate's Ingress already has a load balancer out of the box. That's true, but you don't necessarily have to use that Ingress controller. You can use as kind of Whitney's alluded to. There's a whole bunch of choices that offer different features, and Contour is one of them.
And what, just offhand, and maybe we'll get to this, why would I want to use the Contour load balancer, or really it's an Envoy load balancer over the native Kubernetes one?
Some of that is because, as we're gonna maybe get to, is what Contour adds on top of Ingress and what Contour,
Okay.
Yeah. So kind of the additional things that Contour provides. So
Cool. We have a Physpheric is chiming in. Are there any limitations, considerations to be aware of for, say, resources like CPU, memory, or disk space, and functionality, which could also determine decisions or recommendations for integrating with vendor equivalent products, and or could benefit from using some collaboration between products? So if you're integrating with the cloud ecosystem, presumably, I don't. Are there special limitations and considerations to be aware of? That's what I'm
um,
getting.
yeah. So I think in terms of uh, the way that one, I guess the operator persona would kind of set up Contour is you deploy, kind of going back to our data plane, control plane discussion, they would end up deploying a control plane component, which is typically a deployment, Kubernetes deployment of Contour service, the XDS server, as well as the data plane component, which often is a daemon set, Kubernetes daemon set of Envoy instances, and then to kind of integrate with your cloud provider, you would have a service, which I think James talked about in the Nginx live stream, of type load balancer. So that is a signal to your cloud provider to say, hey, I want you to expose this service running in my cluster. I want you to create a cloud load balancer for me. So Contour, if you're running on a cloud provider that supports the load balancer service, you pretty much have nothing to worry about, except for maybe adding some implementation specific annotations to it. Like AWS requires some particular annotations. Azure might require some annotations. In terms of resources, that kind of depends on what kind of traffic you're serving and how many configuration objects, like Ingress's HTTP proxy objects, you have in your cluster, and how many endpoints. So, kind of alluding back to the Ingress Nginx great explanation that James did on how Kubernetes networking works. Depending on kind of the content of your cluster, you may adjust the resource requirements of your data plane or control plane accordingly. So it's hard to kind of give a categorical like performance number, like you must have
And
X megabytes of memory available.
uh-huh.
It kind of
And,
depends. It's an unsatisfactory answer, but often is the correct answer.
yeah. And generally the more features you want to implement, the more resource heavy it's going to be. Yeah.
Yeah. So
Just
in
I
terms of
think with
integrating with
anything
a
ever.
Yeah,
Hmm.
exactly. And in terms of integrating with a cloud provider, there are things that you have to do slightly differently between cloud providers, but the concept is the same. You set up, you deploy your control plane, you deploy your data plane, and then you expose your data plane to your cloud provider, and then traffic can come into your Kubernetes cluster.
I like that. I like that. Step 1, 2 description. Okay, so we're talking about our personas. We have our cluster operator persona who installs, they set up Contour, and then they can set global policies. Is there something else we want to say about our operator persona?
Not for now. I think we can probably move on to another key persona, which is the application developer persona.
Okay.
So ultimately, in an Ingress controller, what you want to do is end up getting your user traffic. Typically, I guess you would say, is the you have some, possibly a website, some sort of application that is running as pods in your cluster, and you have an application development team that is responsible for implementing the application and then also configuring your Ingress controller, or telling the Ingress controller how they want traffic to get to their cluster, so their applications. So, for example, yeah, you have a website, example.com. It is implemented by an application running in Kubernetes, and you want to tell your Contour installation, please route traffic to these pods in my cluster for requests that you get to example.com.
So they're concerned with getting traffic to their application.
Yeah. So the cluster operator has set up an Ingress controller for them to use, and they are then configuring their Ingress controller to get traffic to their applications. And part of the key here is that this may be many teams, such teams. So many separate teams that are doing this for many different applications, running in a cluster or running in multiple clusters.
So they're concerned with getting traffic to their app, and they're doing that by configuring what exactly?
They may be creating Ingress resources that Contour then reconciles and programs the data plane accordingly, or yeah.
When you say Ingress resources, are you meaning the native Kubernetes kind?
Yeah. Yep. Exactly.
Okay.
And we could generalize that to say creating creating configuration resources to configure an Ingress controller, because there's more than just the native Ingress itself.
Can we say by creating Contour related Ingress resources, and that
Sure.
would no? Okay.
Sure. Yeah. Sure.
And that would include the native Kubernetes one, it sounds like.
Yep.
But maybe that'll segue us into talking about all the Contour Ingress resources. Okay, so we have an application developer or app friends, because it could be a team. Their concerns with getting traffic to their application, and so what they're doing is creating Contour related Ingress resources that have been provided to them by the ops folks. Is that true?
Possibly. So the operations folks might have like templates or sort of guidelines for how to create these things, but typically they'd be creating like a new resource to specify that they want traffic to their applications. They're creating instances of resources, instances of these Ingress or other objects that that end up programming Contour. So we kind of have a split here, right? We have the people who are concerned with Contour running as a whole, and then we have the people who are concerned with their individual pieces of how to program Contour. And that kind of split is where I think Contour shines pretty well, is that we've given you the ability to kind of delegate responsibilities a little bit.
So these are they're no more personas, right?
No, yeah, we can
Okay,
cut it off there. Yeah.
I'll put a box around it, and then repeat. Like this is where contour shines. Delegating, separation of concerns. What's a
Yes.
good way to say that? Separation contour shines because of to help separate concerns between these two personas.
Yes, exactly. So if you look at the structure of the ingress object, uh, it's kind of, I guess you would say, flat. There's not a way to um, uh, let's say, separate out and segment sections of configuring um, the ingress routing for uh, multiple teams, for example. Like, so I guess you could give an example of, um, say you have example.com and you have a team
Mm-hmm.
that's responsible for the uh, the API path. They have a bunch of apps that they need to route based on that, and then you have a separate team that has a separate set of apps, a completely separate team that has ownership of a different URL space underneath example.com. So as you have like a larger and larger organizations, this sort of segmentation kind of increases. You may have very
Mm-hmm.
specialized teams working on a very specialized subcomponent of a larger site or a larger
Mm-hmm.
application. Um, so what Ingress doesn't really give you the ability to do is uh, segment things up in terms of your routing capabilities, in addition to like to reflect the structure of your organization. Um, so this is
So the
where, yeah, go ahead.
okay, the routing capabilities aren't as granular as organizations are needing in this.
Yeah, you could say that. Yeah. So, and the also the permissions models in Kubernetes and with these sort of resources doesn't um, it can be improved upon with the way that Contour structures its custom resource. Um,
Permission problems, routing granularity problems. Okay, cool. Excellent. So we have a question from Kormaju. Can you please brief about service mesh and service proxy? I always get confused between them.
yeah, so you would definitely call Contour not a service. Contour is not a service mesh. A service mesh,
Mm-hmm.
I guess, in the simplest sense, if you're talking about traffic for coming from outside of a Kubernetes cluster to inside, that's what Contour is. Contour is an ingress controller. A service mesh is you can think of it as traffic within a cluster. So you have apps running in different pods and different namespaces within a cluster, and you want to route traffic between that. That's what you would call a service mesh. Um, Service proxy, um, exact definition of that, I guess, sort of means you're uh, using a proxy as a to represent to front a service. So it kind of spans both kind of definitions. It's not like a super.
Is Envoy considered a service proxy?
Yeah, so you can run it. You can run Envoy in many different modes. You can run it as a proxy on the edge of a network, so
Uh-huh.
receiving traffic from
Uh,
uh, directly from clients. You can run it as a reverse proxy. You can run it as a sidecar in a service mesh. It's super flexible,
okay.
designed in to be used in many different ways.
What we didn't say like what is Envoy. what is there a simple definition for like Envoy? It seems to be a flexible proxy.
Yeah, it can be. It's a. I mean, quoting the kind of Envoy documentation, it's a edge and service proxy, so it can be either one. So
Okay. Cool. This is fun. I'm having a fun time.
great.
And service proxy. Okay. Where shall we go next?
Yeah, so I think going talking about what Contour adds on top of Ingress is probably um, the next route to
I
add.
have excellent. I have a question just about how to frame this for the board. We're kind of talking about, you've mentioned, I can't remember the name of it now, but you've mentioned that Contour has some custom resources in addition to the native Ingress object. So should we frame this by talking about Contour's custom resources, or does Contour actually change the native resource somehow?
Yeah, so Contour doesn't uh, do anything special on top of native Ingress. So if you create an
Okay.
Ingress resource that Contour is reconciling, Contour will process that as you would expect, kind of as the spec says. Um, in addition to Ingress, we have our own custom resource called HTTP Proxy.
So a singular custom resource.
Uh, yes, as far as let's go with the one for now. We have a few things that are used for different purposes, but the analogous thing to Ingress that is kind of the improvement is HTTP Proxy.
Okay. There are several custom resources. But okay, HTTP proxy. Because custom are they all capital HTTP
Yep,
proxy?
exactly.
Okay, cool. Okay, tell me what it is and what it does. Or is this enough space, or should I start this over here?
Um, uh,
We'll just
yeah,
go sideways.
we'll go. I don't
We'll
know.
figure it out.
You might need
Okay,
another
this is
board. I don't
my.
know.
Okay.
Um, and yes, Nick's in the chat. Sometimes I wish we had named it something easy to type. Definitely fair point. Lots of T's and double P's. HTTP proxy is a bit of a mouthful saying it out loud. But yeah, HTTP proxy. So you can do
Uh-huh.
everything you can do with Ingress, you can do with HTTP proxy, but it adds some more capabilities.
Okay. So if you can do everything with Ingress if that you can do with this, is there any reason to ever use the Ingress object?
Yeah, some people prefer to use native Kubernetes objects, upstream supported things. They prefer not to use custom implementation specific resources.
Uh-huh.
Maybe for flexibility, right? If you actually anticipate yourself moving between implementations, you might
Okay.
use um, one or the other. Maybe it's just an organizational requirement. Um, it that sort of depends, but
Uh-huh.
to get the full advantages of Contour, we definitely uh, support people using HTTP proxy because it offers more than Ingress, and
Uh-huh.
that's kind of where more of our focus of development has been.
Uh-huh. Young Nick says, we talked about so many other names that were much worse, though. I want to
Yeah.
hear about those. Yes. Um, So it does everything the native Kubernetes Ingress does, but with more features.
Yep.
And let's talk about those features.
Yeah. So the main difference, like there's a lot of things that implementations of Ingress do with annotations that HTTP proxy does, but in a structured in the spec of the resource itself. So that's
I
one of the
like that.
that's
Yeah.
one of the things that is kind of a focus too. Is annotations are at a minimum as much as possible,
Uh-huh.
and everything is in the spec of the resource itself. So things like rate limiting, external authorization, um, configuring, modifying headers and request, rewriting, things like that. That's all in the spec of HTTP proxy itself. So there's a lot more features than probably we can list and would take up too much space on the board, but um, lots of things that you may want to do on and more if people want to contribute them. So shameless plug, please, if you have things that aren't in HTTP proxy that you would like to have, shoot us a line, get in touch, and we can work together to add that.
Cool.
And then another, and so going back to the personas again, so kind of the reason why HTTP proxy exists, we can do a little bit of a slight uh, archaeology session. Before HTTP proxy, there was another resource called Ingress Route, which was similar but different. And the main concept that Ingress Route and HTTP proxy add is the ability to, as we were talking about before, kind of segment parts of your Ingress configuration between different resources that can be owned by different teams or be in different namespaces, for example. So different teams organizationally can take advantage of that functionality
Mm-hmm.
to kind of segment your Ingress space, and that is kind of that's kind of what we were talking about, why Contour shines, the ability to do that, the ability to segment
Mm-hmm.
things up and break up, separate concerns between different
Mm-hmm.
teams.
Um, so can you give an example of that to help my mental model?
Yeah, so we have the concept of a root HTTP proxy, which is where you would kind of think of it like a tree, like the kind of that sort of structure, uh, like the graph concept of a tree. Um,
Mm-hmm.
so you have a root HTTP proxy. That's where you define what host name and some TLS certificates and things for your route. So this is kind of like for example.com. This is where I would say I'm defining that I want routing for example.com, and these are the certificates that my server will serve to for clients to verify example.com. And
Mm-hmm.
then you are able to include different separate HTTP proxy objects that define routing rules. So you can see like you have a top level root HTTP proxy that defines kind of the general site itself, and then you have
Mm-hmm.
different segments of the routing space that different teams can own that have their own separate HTTP proxies.
I
Um,
think I want to draw this out.
yeah, that's a good call.
Okay, and then, but before I do, Kormaju has another great question. I love when Kormaju's here. What kind of service proxy does EKS, AKS, GCP use by default? And how do you use and configure different service proxies like Envoy, Contour on managed Kubernetes?
Yeah, so the second part of that question, how to use and configure different service proxies, that could be something just installing Kubernetes resources via a YAML manifest. That could be that configure Contour, configure a Contour control plane and an Envoy data plane. We have examples in a quick start guide on our website. So the getting started tab on the Contour website is a pretty good way to get started. Could be something like that. Could be with a Helm chart that deploys an installation of Contour and Envoy, or something else like a service mesh. Um, What kind of service proxy does EKS, AKS, GCP use by default? I think that depends on what service mesh or whatever you're installing. So if you're using Istio, then it's going to be Envoy is the service proxy used there. If you're using it for many service meshes nowadays, they'll use Envoy or other. There's some that use eBPF, etc. So it depends on the service mesh that you might be using.
So do all clusters use service mesh?
They don't have to. No, they don't.
Mm-hmm.
They don't have to. It's kind of a an additional thing that you may want to use depending on your use case. It's not required by any means.
Cool. All right, so we're gonna draw. I think sometimes when I draw, I try to like draw up a cluster, but I think I'm just gonna draw the tree that you're
Yeah,
talking about. Does
I think
that
that's a
feel
good idea.
okay? And
Yeah.
so we're gonna route traffic through to different parts of the website. We're gonna make a lot of HTTP proxy instances. That's what I'm hearing. Objects.
Yes.
Is that
Yeah.
correct?
Yeah. So you'll have one at the top that'll define, say, your website.com, Whitney.com,
Mm-hmm.
and that's kind of the parent. That's the root of the whole tree. Um, and then say
Okay.
you want. So go ahead. Go
And
ahead.
so for the drawing purposes, should that just be Whitney.com? And uh, so I guess so we have Whitney.com, and then this is anything in a square is a HTTP proxy instance.
Yeah.
Is
Sure.
that true? Okay. And then so I'm just gonna if it's in a square, it equals HTTP proxy instance. And I'll just make it a square with a blue line. So it's okay. So that means so we have one instance this is saying that this saying is saying when traffic comes into Whitney.com, we're going to do what?
So that HTTP proxy may have specific routing rules that send matching traffic to some service. So if you wanted Whitney.com, like the root Whitney.com, no path to go to a
Mm-hmm.
particular service, a particular page, you might have a routing rule within that root HTTP
Mm-hmm.
proxy that goes to,
Mm-hmm.
say, I don't know, root service, um,
Mm-hmm.
or like your landing page kind of application that's going to serve your landing page. Um,
Mm-hmm.
if you have a separate application that serves Whitney.com/blog,
Mm-hmm.
say that this Whitney Enterprise is a huge organization, you have a whole team managing your blog.
Mm-hmm.
You may have an inclusion rule that
Mm-hmm.
says Whitney.com can delegate to Whitney blog HTTP proxy
Uh-huh.
based on the path. So matching on the path/blog,
Okay.
and that goes to Whitney blog service.
So we have another object Whitney blog. And then all right.
Yeah, so maybe
And
an arrow from Whitney.com to Whitney blog,
uh-huh.
denoting that this is including this other HTTP proxy.
Okay.
So basically, the owner of the top level one, it may kind of be, that may be something that's owned by the cluster operator, that may be owned kind of as in conjunction by many teams, or maybe there's an overarching Whitney team,
Mm-hmm.
Whitney.com team that owns that.
Uh-huh.
And then the Whitney blog object that is concerned with just the blog, um, routing traffic to the blog, that might be owned by in the Whitney Corporation, the blog team.
Uh-huh. Okay. Okay, so this is owned by like a bigger, more wider reaching org. And then this Whitney blog is probably owned by the Whitney blog team.
Mhm.
Okay, cool.
So if there's any specific routing configuration or request modification that needs to go on there, the blog team can own that. That can be in the 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 blog namespace within your cluster that all these apps are running in,
Mm-hmm.
and that can include routing rules that go to whatever blog application or multiple applications that make up the blog. So
Mm-hmm.
similar to how, if we kind of reference the Ingress discussion from the previous live stream, an Ingress object represents kind of path routing rules and ends up routing traffic to services that have endpoints. Same
Mm-hmm.
thing for HTTP proxy. You set up rules within your HTTP proxy that end up routing traffic, matching traffic that comes in based on user requests, and then sends it to services, applications running in your cluster. Um,
So then are there likely to be more HTTP proxy objects underneath Whitney blog for all the different apps that make up the Whitney blog? Like
Possibly, yeah. If your blog is
Whitney,
huge and you have,
yeah.
yeah, many different like pages and things in the blog, you might have
Uh-huh.
many. That tree might get bigger. Going in
Mm-hmm.
that direction, it could, yeah. It totally depends on. It gives you this structure gives you a lot of flexibility in how you may want to structure it as an organization. Um, you can of course do your whole website all in one HTTP proxy. That has advantages and disadvantages, right? Like, um, it's one single source of configuration, but depending on how complex your resource gets, you may actually end up hitting the size limits on how big a resource in Kubernetes can be, because there is a limit to that. Um, um, and yeah, so this is kind of one of the places where Contour shines, is that we give you that flexibility. You can do things kind of whichever way you desire to model your organization. Um,
And then let's say I'm down here at this third tier. My team manages whatever's represented here.
mhm.
If I do I have to concern myself if I need to make a change? Do I ever have to think about these higher level ones?
um, you may, and this is definitely an area where we could have improvement in terms of reflecting desired state and actual state, is you may have to know a little bit about the path that your um, resource is included on. So
Mm-hmm.
whitney.com/blog/foo/bar. You may have to know some of that just to make sure that your application gets the right request data.
Mm-hmm.
Um, that's definitely something that we have talked about improving on. So like,
Uh-huh.
um, one huge another kind of point I want to touch on why HTTP proxy and whatnot is great, is that it adds status information that Ingress does not have. So maybe that's
So
starting a segue to another
it
advantage. But
so
yeah,
uh, is that another way of saying like these higher level ones are discoverable? If I do need to manipulate the team that manages those higher ones, is that in my is it discoverable?
it definitely could be improved on, that discoverability. I think the way we have
Okay,
it now.
cool.
That that is uh, definitely something that can be can be made more discoverable for kind of uh, owners of things lower down in the hierarchy in the tree. Um,
Cool. So all of you future contributors who are watching the stream, here's
yes,
an area. Yes. All right. So we're about to add another feature for HTTP proxy.
yes. Um, so when things go wrong, right? We kind of talked
Mm-hmm.
about uh, how the operator would day two kind of keep all their users happy, right? How an application,
Mm-hmm.
and part of that is also self-service for the owner of an individual HTTP proxy. how do they know that something is wrong?
Mm-hmm.
Right? They've typoed the path that they're
Mm-hmm.
um, trying to include something on, or they have um, misspelled the name of a service, or the certificate is not doesn't actually exist. They haven't created a certificate that's referenced in their TLS details or something like that. How do they actually know that that's happening? With Ingress,
Mm-hmm.
there's no place on the Ingress object to actually tell you that. The Kubernetes resources, the kind of idiomatically kind of work in the concept of the spec is desired state of your object, and then the status of your object tells you what is actually happening in your cluster, right? Have I been able,
Mm-hmm.
has the controller that is implementing this object, has it actually been able to carry out your request, or was
Mm-hmm.
your desired state wrong, like you configured something wrong? um, Ingress doesn't really have the ability to show you that. You kind of have to rely on maybe the controller's logs or some other form of information there.
Mm-hmm.
There's nothing native to the Ingress object itself. So HTTP proxy adds detailed status information showing you, based on your desired configuration, what is going on in the cluster. Is it valid? Is it are there errors? Are there warnings? All that information that would be useful for a developer who's programming an HTTP proxy to know. And then also at the operator level, Contour exposes statistics about that, Prometheus metrics about that sort of stuff. So how many proxies in the cluster are valid? How many are invalid? How many um, are orphaned? So how many are not referenced by a
Mm-hmm.
they're not a root, but they're also not referenced by a root or by in the delegation chain. So they're actually not doing anything, right? So we have this information that adds a lot of the um, a lot to the kind of operational day two, like what happens when things go wrong? What happens when I have a large complex organization and people are flying around making changes to resources all the time, and then they need to know if their stuff is actually working, right?
Yeah. Is it valid? What was another question you said? It adds detailed status info, so it'll tell you if it's valid. What was something else?
Yeah, like
Is it?
detailed information on what errors are there
Oh,
in the
errors.
configuration.
Mm-hmm.
So if you're trying to reference a service that doesn't exist, for example. Um,
Cool.
um, so yeah, that's one of the real big advantages of why we think uh, HTTP proxy is attractive to use, is because it gives you some of these things on top of Ingress, all the things that Ingress does, but a bit more, and a bit more operationally that make your life maybe a little easier.
So I have a question. Could you use the native Kubernetes objects in this tree pattern also, or is that unique to HTTP proxy custom resource?
Um, Not at the moment, but that's an interesting. I think that's some thoughts that we've had in the past. Kind of, how do you integrate different types of resources together? It gets a little bit complex, but I'm sure if someone really needed to, we could figure that out. But
Mm-hmm.
at the moment, your tree is of all
Yeah,
HTTP proxies, but you can still use HTTP proxy and Ingress and Gateway API all at the same time if you really needed to.
I love that. But also, I think you kind of answered this, but my question was more about what if you wanted to make a tree that was 100% Kubernetes Ingress objects? Is that possible?
Not at the moment. No, I think
Okay.
that would have to be using annotations, uh,
Mm,
because the Ingress object itself doesn't have this um, defined spec fields for that. So you could probably make that work. Contour
mm-hmm.
does not, because we think that it's better to do with our own custom resource. But um,
Yeah.
yeah.
Cool. Awesome. So, do we have more to say about HTTP proxy, or I heard you say gateway API?
Yeah,
Is
so
it time?
I think it might be the time to start going in that direction. Um,
Woo! exciting.
Yeah, so we can kind of see a progression here a little bit, right? We have Ingress, we have HTTP proxy form. There was another predecessor to HTTP proxy called Ingress Route, which has now been deprecated. But HTTP, you can kind of see a progression. We've added some functionality on top of Ingress, informed by on top of Ingress that became HTTP proxy that was informed by Ingress, right? And kind of some challenges and additional features. There's kind of a new generation now called Gateway API that is informed by Ingress, informed by HTTP proxy, informed by other implementations across the industry. That kind of takes some of these concepts and kind of puts them all together in a not a single resource any longer, but a collection of resources instead. So
Gateway API is not contour specific, right?
no.
All right. So what is Gateway API?
All right. So at a high level, it's kind of a new way to model service networking and ingress and service mesh in Kubernetes. So it kind of spans many different subject areas, but for the context of ingress and contour, it's a new way of modeling service networking that is represented by a collection of resources, as opposed to with ingress just one, with HTTP proxy pretty much just one resource. This is not a it's not quite the same as Ingress in that it's owned by by the SIG network working group community, but it's not a in tree, so it's not a core set of core resources. They're developed outside of the core Kubernetes tree for various reasons, because as we saw with Ingress, adding things, changing things are reliant on Kubernetes versions. Movement is developing things at a fast pace is a little bit harder. API deprecation, et cetera, et cetera. So it's a set of custom resources that you can install in your cluster, and you need a gateway implementation. So something like Contour, something like Istio, something like Envoy Gateway, something like Kong, they all implement these resources in their own flavor, right?
Something I find confusing about Gateway API is especially at first, API Gateway is also a thing, and so anytime I start to say I talk about either of those concepts, I'm like, wait, which way does it go?
Yeah, definitely. It used to be called Ingress v2, and then Service APIs, and now it's called Gateway APIs.
So what are some examples besides Contour of Gateway implementations?
Yeah, so there's Cilium, Istio, Kong, Nginx also has a implementation. Traffic.
Which Nginx though? The Ingress Nginx we talked about yesterday, Nginx Inc. We have a comment. They will all provision their respective cloud load balancers if you define a Kubernetes service of type load balancer in your Kubernetes cluster. So I think this is an answer to Kamaraju's question.
Yeah, definitely.
Up here. Thank you so much, man. Cool. So are we going to talk about the different Gateway API resources?
Yes, we will.
Exciting.
So if we look at the progression here, Ingress to HTTP proxy, we had this addition of this sort of roles and role-oriented kind of structure. Gateway API takes this to even further level where this sort of separation of concerns of roles is actually separated between different resources, or can be modeled as being separated between different resources. Um, so first, I guess at the top of this hierarchy of resources, you have something called a gateway class.
Are the separation of, persona separation of concerns?
Yeah.
Am I off the board? Okay, of concerns. Cool. All right, and so at the top of the hierarchy, well, I'm just going to write these as a list because I'm running out of space. So, what's the first one?
Yeah. So gateway class. So
We're talking. This is a custom resource, right? And it's called gateway class, like all one word.
yes, gateway class.
Okay, cool. Thank you. Probably like this.
Yes, perfect.
Great. Thank you.
Yeah. So this is, I guess I don't remember if James talked about this in the Ingress Nginx one, stream, but when we're talking about kind of a later addition to the Ingress ecosystem was the concept of an Ingress class, which is a separate resource from Ingress that allows you to specify kind of what implementations should implement this Ingress. So it kind of allows you to say you have multiple Ingress controllers running in one cluster. You could separate them out and say these Ingress resources are only implemented by Contour. These ones are by Nginx. These ones by Istio or something like that. Gateway class is a similar concept where you have a kind of overarching resource that represents this is the type of then gateways. Gateway is the next level down of resource. That's the next resource that we're going to talk about. It's the type of gateway that is going to be implemented. So a gateway class includes a reference to kind of a generic reference to a spec field that allows you to reference a kind of a generic configuration object. So you may have in this class of gateways, you may want to do all like configure your contours all in the same way, right? That implement this. So it's kind of it's a way that it's kind of targeted at the infrastructure provider gateway persona. So something like for example, another implementation of gateway API is like a cloud provider. So like Google Cloud may provide a gateway class into a cluster that you create in Google Cloud that allows you to say, okay, when I create a gateway, it's going to be of this type, and it's going to do, say, it'll create a external IP for you or something from this some range. So that's gives the infrastructure provider or that persona the ability to kind of provide that sort of framework, like template almost of what a Ingress controller would look like, or what an implementation of a gateway would look like.
Excellent. That's very helpful. So gateway class, it's an overarching resource that defines the type of gateway that will get implemented.
Yep.
So, for example, like all Contour resources will be configured the same way, or all of this cloud provider resource is defining at that level. We have a question. First of all, is that correct before a good capture?
Yep.
Okay. Does Contour expose metrics about individual targets, application pods? So request count, latency, or only aggregate across all application pods?
Yeah. So this is where we rely on. We touched on earlier about Envoy, about the observability of Envoy. So Envoy is the data plane for the Contour Ingress controller, and Envoy by design has a ton of statistics that it collects on the on request routing, on request latency, all of that. So the I don't have a link right now. We can probably add it later. But the Envoy, various Envoy documentation pages on the statistics that it exposes has all sorts of information about this. So you can see. So an Envoy cluster in Envoy parlance, that's maybe a collection of endpoints that Envoy is proxying to. That there's statistics per cluster for that, and you can see HTTP errors, timeouts, all those counts of things from the front end of Envoy. So from the what Envoy and Envoy parlance is downstream requests. So from your client to Envoy itself, there's all sorts of statistics about that. Yeah, really the Envoy like you can spend forever finding interesting details about your data processing and processing of requests with Envoy. So yeah, definitely.
Thanks so much for the question, Mintu. All right, so then I think you said the next level down is a gateway object.
Yes,
Is that
a
correct?
gateway object. Yes, this is kind of where we're getting closer to the previous personas that we talked about with Contour. Is you would this is kind of focused on the cluster operator persona, right? Like, so if I am a cluster operator who is running a cluster and I want to provide an Ingress controller to some set of teams, I would then create a gateway that is attached, references a gateway class. So this is of some type, and that would cause a in the context of Contour, that would result in a Contour an installation of a Contour. So Contour server control plane and data plane combination that would result in that being deployed in your cluster. So
the gateway is the instance of the Contour.
Yeah, that's kind of one-to-one at the moment. Things may change at some point with merging gateways and whatnot, but at the moment we like to think of a gateway is one-to-one with an installation of a Contour. And that would be kind of the focus of the cluster operator to start setting that up.
And in a more general way, it's a one-to-one with an installation of an Ingress implementation. For example, Contour.
Yeah, you may that may, depending on the implementation, that things may slightly change, but in general, we can say that, yeah.
Of a compatible Ingress implementation.
Yeah.
All right.
So yeah, in the context of Contour, that will mean that you get a control plane and a data plane configured, and you also, as part of configuring a gateway, you start to be able to specify what address you want this gateway to listen on. So that'll impact like the service that Contour that is deployed to expose your envoys to the internet or not.
So in the context of Contour, it installs and configures a Contour instance, a Contour what?
We could just say control plane and data plane.
Okay. All right. Am I going off the side yet? No. Cool. No.
And then, so part of the key parts of a gateway are listeners. So we have.
Is a listener its own object?
No, a listener is a spec field, a list within gateway.
Okay.
And a listener, you can define similar to like this is somewhat related, like the maintainers of Contour, Nick and Steve and others were involved with Gateway API at kind of the formation, and they're still involved with Gateway API. But this kind of influence of that root HTTP proxy that we talked about, like so that Whitney.com. This is kind of where that filters into Gateway API. So a gateway listener, you start to define that sort of overarching top level things like that. So like a listener within a gateway would specify, okay, I want Whitney.com. I want to configure my installation to with a listener on some port. So say port 80 for plain HTTP traffic. I want it to be tied to, I want Whitney.com to be routed through this port. And then I want to be able to select certain routes, so route configurations that are tied to this listener. Yeah, so port, host, protocol, TLS certificates, all of that is configured on a listener.
TLS certs. So if we have the real estate, I'll write out this sentence like Whitney, like an example with Whitney.com. But if we have a lot more, I'm not going to write it out because we're running out of space.
Sure.
Which one is it? How many custom resources related to Gateway API are we going to talk about?
We have, at the very least, we have one, but we could talk about a few more. We could talk about
okay. Then let's leave the example out, and we'll stick with the meat.
Sure.
Okay.
So we have our overarching description of what the listener will be, what sort of traffic the listener is going to match on, and then we also have another set of resources that that listener can reference, which are routes. So that could be HTTP route, TLS.
And the route is a resource, is a custom resource.
Okay. Yeah. The routes, there's a few different types of routes. They're individual resources themselves, but we can kind of put them in the same bucket.
Okay.
There's HTTP route, TLS route.
Is it called HTTP route?
Yes. Yeah. TLS route, TCP route, UDP route, and a newer one called gRPC route.
UDP. Is the G lowercase?
The G is uppercase.
Okay. I'm not even sure I'd recognize the protocol without the lowercase g at the beginning, you know? Okay.
Yeah.
So, cool.
So, yeah, a listener can then can select various types of routes. So you can say that I have a listener for port 80 that's going to select HTTP routes, and basically signifying and combined with the protocol that you configure that listener with, you're configuring basically HTTP traffic to be proxied, and in the context of Ingress with Gateway API. You could similarly do something with a different protocol. So if you wanted to proxy UDP, for example, with Contour as an L7 only proxy at the moment, we may implement TCP route at some point, but another implementation may want to support UDP and say, oh, I'm going to have a DNS server and expose port 53 with my gateway listener and select UDP routes or something like that, right? And so routes are then kind of what the core of Ingress and HTTP proxy is. That's where you define your routing rules. So like this path will go to this service. This request that match this path and this header will go to this service, and a few other things. So that's kind of where the routes are the meat of what the application developer will be involved with. So this is where that persona gets involved. Kind of have these few layers of separation of concerns. And yeah, you can kind of see the parallels to HTTP proxy, right? The
Mm-hmm.
um, it's now segmented into completely different resources, so you can use different sort of permission models with RBAC and whatnot in your cluster to separate concerns. So only give application developers access to HTTP routes in a certain namespace. That now you can do that even more effectively than with HTTP proxy, right? Because it's completely separate resources. The roles are more well defined in that sense. Um, so that's kind of like one of the biggest draws of Gateway API is the ability to do this sort of segmentation. Um,
Mm-hmm.
on top of what other implementations like HTTP proxy have done. And there's even more extensibility to Gateway API that HTTP proxy that can be added on top of HTTP proxy, right? So a gateway, you can possibly implement your own custom route type if you wanted, because the reference in a gateway listener is kind of a generic uh, group object name field. So you can, if I wanted to, if we wanted at Contour to implement our own special route type, we could, and we could reference it in the gateway listener and do that. And there's all sorts of other extension points within the gateway API that make things extra flexible.
So I need a little help grasping, or maybe it's just a question. So once the Gateway API is fully integrated with Contour,
Mhm.
how does are you using your HTTP proxy custom resource in addition to these Gateway API resources, or do the Gateway API resources replace the Contour resources?
Yeah, ultimately they can. Not everything in HTTP proxy is in gateway API at the moment yet, but in the future it possibly will be. So when you have a Contour installation in your cluster and we see Gateway API resources, we will program Envoy with the content of those Gateway API resources. You can also
Okay.
have HTTP proxies alongside them if you want to as well. But like, yeah, if I understand the question well, it is kind of like it's the same as the relationship between Ingress and HTTP proxy. It's like the same, but it's a different way of implementing the same idea.
Could I put, if I'm an application developer and these HTTP proxy instances already exist, and now the Gateway API rolled out, can I make a route at my lowest, at my level of the tree?
This is a kind of an active area that we've been talking about is like
Uh
how
huh.
do you do the migration?
Yeah,
Um,
yeah. I guess that's really the base, what my question is, isn't it?
yeah, so
Uh
if
huh.
you wanted to take if you were a sophisticated organization using tons of HTTP proxies and you want to make that
Mm
migration over to Gateway API because you see
hmm. Mm hmm.
advantages there.
Mm hmm.
Again, you don't it's similar with the Ingress to HTTP proxy, you don't have to if you don't need it.
Mm hmm.
But if you
Mm
do
hmm.
see advantages there and you want to move over,
Mm
that
hmm.
migration is something that we're definitely talking about. One
Mm hmm.
idea is could you reference HTTP proxies from a HTTP proxy objects from a gateway? So I kind of mentioned
Mm
that the listener's
hmm.
route selection idea that allows you to just kind of specify whatever that you
Mm
want to
hmm.
select. So we could
Ah,
do that as an implementation specific thing in Contour, maybe.
cool.
Um, that sort of migration process is kind of thoughts in the moment.
Uh
At
huh.
the moment, there is a tool that's owned by SIG network in the Kubernetes SIGs organization called Ingress to Gateway, which actually tries to convert Ingress objects to Gateway API objects. So
Oh,
that
interesting.
migration path is something also that we got to think about. Um,
Yeah.
and then similar, as you said, for Contour to Gateway API, that's another migration path. So yeah, definitely active thinking about that. Another plug to please get involved if this is relevant to you. If you see HTTP proxy as useful, but you also see use in Gateway API, please let us know how you would how that relationship would work for you, like what sort of constraints you have in migration. That would be wonderful to get that input as we're designing this. But Yeah.
Amazing. Cool. So we have like probably enough board space for like one more new custom, like Gateway API custom resource, or anything else you feel like you want to fill that space with.
Yeah. So one concept that's brought over from things like HTTP proxy is um, that idea of reporting desired state and actual state, and that's brought over into Gateway API resources. There's a big focus on defining um, what status means in these
Mm-hmm.
resources, and uh, um, what's actually reflected in your cluster, and informing developers of that. Um, so that's they got a nice comment from
From Nick, the first one. Wow, 2 days in a row, Whitney. Thank you for that gift. I'm um I'm tackling a lot of stuff, and so I think for a while I'm going to be doing 2 episodes a week. Except no, next week I'll be in Denmark. But thanks so much for being here, Nick. And yeah, you're the best. Cool. So this whole status information thing is something that concerns a lot of people, and it's something that's being considered as part of Gateway API specification.
Yeah, definitely. That's a big focus of Gateway API is being able to tell users what is going on in their cluster, right? That's kind of one of the struggles that many people may have had with Ingress. Um, um, so yeah, if we want to talk about more resources in Gateway API, we definitely can. There's a bit more to talk about if we want to. There's the concept of a reference grant, which is another custom resource. Um, uh, didn't mention it before in the context of HTTP proxy, but we have a resource that Contour provides in addition to HTTP proxy called TLS certificate delegation, which
Mm-hmm.
offers like a safe way to reference secrets across namespaces. Um,
Mm.
Often namespaces in Kubernetes are used as kind of units of ownership, right? Like a particular team may have access to one namespace, but not another one. But
Mm-hmm.
you may also want to uh, host all your secrets or all your TLS details in a particular namespace for management reasons, or
Mm-hmm.
what have you. Whatever reason, there are many reasons to have objects in different namespaces, but you
Mm-hmm.
don't want to just kind of give um, uh, everyone access to everything, right? You want to kind of constrain uh, what certain certain personas can configure in a resource to reference across namespaces, and so on. So the TLS certificate delegation in Contour allows you to kind of have I think uh, one of the ways we kind of talk about it, and I think is a nice way to say it, is kind of like a handshake, right?
Uh-huh.
So you have uh, a resource wants to reference something in another namespace, and to allow you to do that, we have uh, a resource that basically says you're allowed to do that, right? So kind of the bidirectional, like, I want to do this. Okay, you are allowed to do this. That same idea is in reference grant, that is in core part of the Gateway API, and
Mm-hmm.
may also be expanded. I think there's a enhancement proposal. I believe it exists to add this to the core Kubernetes APIs to kind of be used generically. Uh,
Ah.
so
So
go ahead.
yeah. No, I was just gonna. It gives permissions as far as I've gotten in terms of what it does exactly. To
Yeah,
it gives yeah to a service account, to humans, to whoever.
this is kind of on the level of um, allowing references in one resource to things in different namespaces. So you can control the access rules on the RBAC level, but also you need to have um,
Hmm.
trust these sort of trusted additional trusted kind of handshake mechanisms to be able to give you access to resources across namespaces. So for example, if I have a gateway in a particular resource or in a particular namespace or an HTTP route in a particular namespace, but my
Mm-hmm.
TLS certificate or my service that these resources are referencing is in another one. We kind of want to have a trust relationship to kind of make sure that reference is valid. Otherwise, you can kind of you can see malicious things going on, right? You can kind of, if you someone
Mm-hmm.
in a multi-tenant cluster, if I can kind of guess at the names of services in other namespaces or the names of secrets in other namespaces, I can kind of do some nefarious things. So if I have if you have this construct of reference grant, which is a core concept in the API, and it's part of the conformance testing, conformance tests that are set up for Gateway API,
Mm-hmm.
that allows you to kind of control that and have that sort of trusted reference relationship across namespaces. It's a cool concept.
Yeah.
It's something that could be coming to core Kubernetes sometime soon. I forget what the status of that is, but yeah.
May come to core Kubernetes. Great. So I understand there are more, but we just don't have room for more. I was going to write about core Kubernetes, but I changed my mind. Um, can you give me a sense of how many are there, like tons of gateway API resources we didn't cover, or a few?
Actually, I think we probably covered all the custom resources. There's maybe more
Okay, features or
concepts and
functionality.
features that we could cover that kind of
Mm-hmm.
encompass custom resources that implementations could create that can be referenced by Gateway API objects. So that's
Uh-huh.
kind of like a hint towards the extensibility aspect of Gateway API. There's all
Uh-huh.
sorts of points within the specs of these resources where you can reference kind of generically reference things. So that could be implementation specific custom resources. It could be core resources that you like, services that you put in certain places, or maybe depending on the implementation, right?
Mm-hmm.
So that's a huge area of discussion and development, um,
Mm-hmm.
and it kind of shows a lot of the power of Gateway API um, to be very flexible. Um,
Mm-hmm. And Lord knows we need some standardization in the Ingress space.
yeah, exactly. So
Mm-hmm.
like this, um, part of the value proposition of Gateway API in some sense is to be able to, um, at least for the core set of functionality. So one of the big focuses of Gateway API is the conformance testing. So
Mm-hmm.
um, making sure that implementations of Gateway API are conformant to the specification. Something that existed for Ingress, but was somewhat limited just because also the scope of Ingress was small. Um,
Mm-hmm. So
um,
wait, the conformance testing, who's doing that and what are they testing? Is that I don't follow.
yeah, so the
Is that
Gateway
the
API project, like
mm-hmm.
within the Gateway API repository itself, there's a set of conformance tests that are maintained by the community, that reflect what is written in the spec of all these resources and in
Mm-hmm.
actual tests. So
So is that at the implementation level?
yeah, exactly. So for
Okay.
Contour, we would take these tests. We would have an installation. We have Contour running in a cluster. We run these tests against in that cluster with Contour and make sure that Contour passes.
Got you.
So these are
I
like kind of
see.
generic, like routing tests. Like when I have
Mm-hmm.
an HTTP route, the right thing happens. When I have a reference grant, when I don't have a reference grant, then I don't allow traffic because I don't have a reference grant, or I get certain status messages on the resources because there's no reference grants, things like that. So
Mm-hmm.
all this like core functionality that should be implementable across the board by any implementation of Gateway API that focuses on these certain areas. So that gives users kind of the ability to know, hey, this is
Mm-hmm.
going to work as I expect it to, and you can also
Mm-hmm.
possibly shop around a little bit. You can use Contour in some clusters. You could use Istio Ingress and Service Mesh in some clusters, and it's all kind of going to work. The core functionality is going to work.
Yeah, so it allows you to be more tool agnostic than you can right now.
Yeah, exactly.
You could, yeah, if you decide you want, if you're maybe already using Nginx and you want to switch, assume, and you want to switch to something that uses Envoy, you could, and you're using all gateway custom resources, then hypothetically you should be able to switch between the two
Yeah.
without too much resistance.
Yeah, exactly. Like if you have certain organizations might have different types of clusters that have different requirements, right? Might use different.
Mm-hmm.
You want to use the same configuration substrate, kind of to use
Mm-hmm.
that word, which is
Mm-hmm.
relevant here, and but have it implemented by different controllers, different implementations within one cluster, within different clusters, whatever have you. So, yeah.
Excellent. Well, if anyone has any more questions, y'all have been great about asking. There have been some really good questions today. But if you have any, please speak up because we're starting to wind down. So, what I'm going to do, Sanjay, is go through and do a recap of the episode and make sure that everything I've written on the board captures the story of what that you've told today and what you've taught us today, and make sure the understanding is clear. And then, just as a fair warning, when we say goodbye, we're just going to dance a little bit. I'll put the intro music back on, and we're going to dance. Physpheric says, "Great show. See you next week for another episode of The Way of the Glowing Pin." I won't be around next week, Physpheric, but I will be around the weekend after next. I'm going to start tackling Kubernetes policy tools. So we're going to do open policy agents in Kyverno on June 1 and 2. Next week, I'll be in Denmark speaking at a conference with Victor about our YouTube stuff. Kormaju says, thanks for both enlightens. Thank you. Thank you. Thanks for your great questions as always. Excellent. I'm going to start this recap. Let's do it. Are you ready, Sanjay? You feel good? Is there anything you want to add before I go?
No, it's been a pleasure.
Okay, great. This has been really fun. So we first talked about why is Contour created. So the idea of needing Ingress, needing a way to get traffic into the cluster was not a new idea, but this technology Envoy emerged, and so using Envoy as a data plane in the cluster is very, very appealing. And so that's one reason to do it, and I'll get into exactly why later. And then another reason that Contour was created was wanting to improve on this native Kubernetes Ingress object. So let's talk about both of those things in depth. But you said this like nice little piece that like took up this much of the board, and then I'm like, okay, what's Envoy? What's a data plane? What's the native? Like I had to unpack all the different concepts. So we talked briefly about like what is a control plane versus a data plane in Kubernetes. And what's important here, this is in the context of Ingress. Because I've heard of the data plane being used to reference a way to move data, data around in your cluster. And in this thing, we're talking about more routing capabilities. Data plane means more routing here. So a control plane is concerned with the actual state versus the desired state. And so the input is the desired state, and then the output is configuration for the data plane. And so then the data plane receives that configuration and does the work. So in Ingress, it does the routes. It will like route and requests and potentially modify those requests. So then why Envoy? So Envoy is at the one big thing about what makes Contour alluring. So even if you already have an infrastructure totally built on native Kubernetes Ingress objects and you have no intention of switching to the upgraded HTTP proxy object that Contour can do, you still may want to use Contour just because of the Envoy capability. So Envoy is an edge and service proxy. I know from talking to Alice Wasco in the Emissary Ingress episode that Envoy is notoriously difficult to configure. It's I also talked with Flynn, who's part of the Linkerd project, and he just says it's not meant for humans to interact with directly. Like, it's so complicated. So Envoy, but with that complexity comes a lot of features, and so it's well tested. It has a super big community, which means it's going to be well maintained, and new features will come out regularly. It's secure. It's extensible, so you can add your own custom extensions. You can inject scripting. You can use different languages. You mentioned Rust, Go, and C++. It has dynamic configuration reloading. So our friend from chat, whose name I forget now, said that solves a problem of dropped connections. It looks like you want to say, who was it in chat who told us that?
Shout out to Steve Sloka.
Yeah, thank you, Steve. It's also scalable, so it can scale very large. So clusters these days can be super duper huge, and Envoy can handle that. It has observability functionality. It's collecting numbers and metrics for you, and you can access those. And then there's more functionality that we didn't get to, but that is even if there isn't anymore, it's pretty great. So and still unpacking this little statement at the beginning, we talked about the native Kubernetes Ingress object. So it is, it said it's a little bit flat. So it takes in host and path and service and TLS certificate as a way to tell your traffic where to go. So it's a way to get traffic that's external to the cluster into the cluster with these parameters. If you want to add additional functionality to the Ingress object, that's often done with annotations. So annotations, they get the job done, but they're unstructured data in the end, and it's complicated to keep them consistent. And also, a native Kubernetes object can't show you when something is wrong or what exactly went wrong. So you're kind of blind if there are errors in the way you've configured it in the first place. So those are some limitations of the Kubernetes object. So now we're finally to what is Contour. So Contour is a Kubernetes Ingress controller that uses Envoy as a load balancer and proxy. And then I almost feel like we should, in this definition, mention that it also because this definition doesn't capture what we talked about in the HTTP prop. So it uses Envoy as a load balancer and proxy, and it offers some additional features to the native, above and beyond the native Kubernetes object. What do you think about adding that into the thing?
Yeah, that sounds great. I think you stated it very well. I was trying to say that earlier, but I think the way that you said it right there was perfect.
With additional, I'm not going to use the word some. No, cool. Kubernetes Ingress object. So let's say that again. So Contour is a Kubernetes Ingress controller that uses Envoy as a load balancer and proxy with additional features above and beyond the Kubernetes Ingress object. And we'll get into those additional features here in just a moment. So in talking about the additional features to the native Ingress object, Contour especially shines in a multi-team use case. So it can address the different teams and different people in a large organization in a much better way than the Kubernetes Ingress object can. So we defined a couple of personas. One is the operations person, ops folks. They install Ingress cluster-wide. They manage traffic for the whole cluster. They're interested in integrating with what's running in the cloud provider. They need to maintain the Ingress implementation. So they're going to, in the Contour specific way, they're going to set up Contour. They might set global policies. So for example, they might set up request headers that go on all of the traffic that comes through the cluster. And then we have another persona, which is the application developer or app friends, because it could be anyone on an application team. But they're basically just concerned with getting traffic through to their application, and they don't care about all the rest of it. So if and so they're concerned. So they'll create Contour related Ingress resources, and there are going to be many types of teams, many teams in org that will consume these resources and need to work well together. So the native Kubernetes object doesn't do well for these two different personas because there can be permission problems and there can be problems with routing granularity. So there's several custom resources in Contour, but the one we dug in on today is the HTTP Proxy resource. So it does everything that a native Kubernetes Ingress does, but with more features. And to be clear, if you're implementing Contour, you use this resource instead of using the Ingress objects, right? Not in addition to. So yes.
Yeah, definitely. You can still use Ingress, but you can use HTTP proxy instead if you prefer to use the extended functionality.
Excellent. So the more features we talked about mean they're minimum annotations. So those extra capabilities that used to be added as annotations instead with HTTP proxy, they're added to the resource spec itself. So now it's structured, and there's a lot of different functionality you can add in that way. The examples you gave are rate limiting and adding headers. But you said there are many examples, so many that we could take up the whole rest of the board with just examples of extra things you could do as part of the spec itself. It can separate concerns between teams, which we'll talk a little bit in our charts here. It adds detailed status info. So it solves that problem of the native resource not being able to tell you when something's wrong or what exactly went wrong. So we could say the HTTP proxy resource can say, is it valid? What are the errors? It can also give you statistics for operations folks. And then we also talked about TLS certificate delegation. So it's a safe way to reference secrets in different namespaces. So those are all things you can do with the HTTP proxy resource that you cannot do with the native Kubernetes Ingress object. We have a comment right now from Min2. All these notes on the board are a great starting point to brief my colleagues on Contour. Can I ask for an exported version after sharing and I can use it? Yeah, you can DM me on Twitter or on LinkedIn. Yeah, hopefully you can find me. Do your best. Twitter and LinkedIn seem like a good way. I don't think, if you go to tanzu.tv/Whitney, I'm there. Hopefully you can find me in the wide world, but I'd be happy to help you in any way, certainly. So then we decided to draw out what this looks like because the HTTP proxy resource can be nested with itself. Many instances of it are meant to be used together. So we talked about an example of that. So all of these different blocks represent different HTTP proxy instances. So we might have a parent instance like Whitney.com. So that one might be owned by the ops folks, like at the operations level. Or maybe there's a Whitney.com team. There's several domains across the organization, and there's a Whitney.com team. And then there's more granular. There's a Whitney blog page, and that's owned by the Whitney blog team. And so this Whitney blog instance of an HTTP proxy resource would include routing rules for the many apps that make up the Whitney blog. And so then we have maybe at a third level, and this could go turtles all the way down for a while, right? There are more HTTP proxy objects that can be added with routing rules for those apps. But the people who own the different objects at different levels can be different and more granular to their whoever's working on that exact piece of the whole company's website or estate. So that's Contour in a nutshell as it is today. And then we got into Gateway API, which is the future. Oh, we have a question, and I have a question. My question, don't answer it now. We'll answer theirs first, but I'm going to say it out loud so I don't forget it. My question is, what is the timetable for Gateway API? When can we expect for some of these features to start rolling out, and especially for them to be beta, I guess, or V1, where they're safe enough to be used at a larger level? And then we have a question from Hans. Can you explain why you chose Contour and not Traffic? Why I'm choosing to do this episode on Contour? Well, I'm doing episodes on every CNCF Ingress option. So I've already done an episode on Emissary Ingress, and I did one on yesterday on Ingress Engine X. And then Contour is the third CNCF option for implementing Ingress. And so that's why I'm doing Contour today. And I'm happy about it. This has been a really great episode. So, this is a question for you, Sanjay. What is the timetable?
So currently, the majority of Gateway API resources, so Gateway class, Gateway, HTTP route, let me look at the actual TCP route, TLS route. They are all in the beta API group.
Okay.
Sorry, I should rephrase that. Not TLS route. So reference grant, HTTP route, gateway class, and gateway are all in the beta API group under the gateway namespace.
Cool.
So those are available, and the gRPC route and TCP route, TLS route, UDP route, those are still in alpha. The Gateway API has kind of a newer kind of model of doing version compatibility and whatnot. So the Gateway API repository itself will release like semver tagged resources, releases. So we're on version 0.7.0 right now. Version 1.0 is coming, I think, this year. Official GA. But within a release, you will have kind of a standard and experimental channel of resources. So the standard channel has all the resources that are in currently beta, but will be GA once GA happens. So will be V1 once V1 happens. But the experimental channel has all of those plus the alpha resources, so the experimental resources, and the standard resources will also have some experimental fields that have been added later. So there's kind of like a multi-tiered approach to versioning here. So yeah, hopefully that answers.
Yeah, it absolutely does. And that seems like the wise way to do it. I like it. So, what is Gateway API? So Gateway API is a new way to model service networking in Kubernetes. So it's a standardization across Ingress implementations, which we've kind of talked about how confusing it is to enter the Ingress space, and hopefully this will help with that. So it's represented by a collection of resources, which we'll get into. And you need a Gateway API implementation. So this is a standardization, not an implementation. So Contour is a Gateway API implementation, as is Cilium or Istio. So a service mesh will be using Gateway API, not just Ingress. Kong cloud providers will implement Gateway API, for example. A Gateway API is owned by Kubernetes SIG Network Working Group, but it won't be a part of the Kubernetes core database because it doesn't want to be tied into the Kubernetes release cycle, which can be slow. The implementations, if you're implementing Gateway API, your implementation must pass conformance tests. But these collection of resources, again, are meant to address this separation of concerns between personas and different people concerned with routing traffic at different levels in an organization. So we talked about 4 Gateway API custom resources. First, there's Gateway Class, which is an overarching resource that defines the type of gateway that will be implemented. So it's going to define, like we talked about these Gateway API implementations that have to pass conformance tests, you define which implementation you're using at the gateway class level. So if you're implementing Contour, that's where you define that you're implementing Contour. The gateway is a one-to-one resource with the actual installation of the implementation. So in the context of Contour, it'll install and configure a Contour control plane and data plane. And the gateway and the gateway class are both intended to be used by the operator, the cluster operator persona. The gateway resource has a field in the spec called listener, and that's where you're going to specify the ports, the host, the protocol, and the TLS certificates. So then you have a routes resource. There are lots of different route resources. So there's HTTP routes, there's TLS routes, TCP routes, UDP routes, gRPC routes, for example. There might be more. Are there more? Or is that it?
There may be some custom implementations of of route resources that make more, but in the gateway API itself at the moment, these are the
them.
ones. Yeah.
Got it. So a listener, so the app friends persona is the one that's concerned with the root resource. So but at the gateway level, that listener is where the root type is defined. So an app friend, so it might be a gateway might use an HTTP route, and then the app friend persona would define their own HTTP route instance, and that's where they would define their routing rules to get traffic through to their particular app where they want it to be, because that's all they care about is the end user being able to get through to their application. All the rest of it can fall away into oblivion as far as they're concerned. Finally, we talked about a reference grant resource, which gives permissions to resources to access stuff in different namespaces. So specifically, probably Root's TLS certificate, the secret is going to be hidden in a secret in a certain namespace that's not the namespace they're in. But I suppose it could be used for other use cases too, but that will be a common way to want to do that. We have another question in chat. Hello, you're here again today. Thanks for coming back. Can Contour manage multiple Envoy load balancer IPs? When we deploy first, by default, it deploys single Envoy load balancer service.
Yeah, so the Envoy load balancer service isn't, I guess you could say it's not technically intrinsic to Contour itself. It's a way to expose your Envoy pods that are serving, like acting as a proxy to the internet, possibly. So depending on your setup, you could possibly have multiple, if you need multiple IP addresses or something. What Contour does do is that we do keep track of of a single load balancer service, so that we can put the IP address that's assigned to that load balancer in status of an Ingress object, of HTTPProxy object, of a gateway. So that informational stuff is there. I think we have some issues open about supporting multiple services. So if you're interested in that, let us know. Come talk to us on GitHub or on Slack or wherever. Yeah.
On Slack, if you want the teams in a Contour channel in the Kubernetes Slack workspace.
Yeah, the Kubernetes Slack workspace, the Contour channel, and there's also the SIG Network Gateway API channel as well, if you are interested in Gateway API in general. So
cool. So do you have anything to add or maybe gently correct me about everything I said in the recap? Do you feel good about it?
I feel great about it. I think
wonderful.
It's taken a great. I love the way that the board has flowed, actually, and it all connects together, and I think it's a really great summary.
Yeah, I think you just did a really great job of teaching. So thank you so much. And thanks everyone for coming and asking wonderful questions like you do. I very much love how kind and welcoming the space here is. And thank you everyone also who watches the recording. We're gonna dance our way out of this show. So everyone have a wonderful, wonderful day and a wonderful, wonderful week. And let's dance our goodbyes. There we go. I turned it down. There we are.